So what we're going to do now is a second video exercise for engineering equation solver, simple Rankine cycle. We're going to put in information on the diagram window, figure out how to use that, and we'll probably do a simple plot and show why we need to add some extra points for the simple cycle to make the plots come out properly. So first of all, let me go through, run this again, make sure everything is up to date. We've got our table is full. So what we want to do, quick and dirty, we're going to add output variables. So output variables are going to be items basically from the array table. And also from the solutions window, because we don't have an array variable associated with the turbine power and the pump power. So let's go ahead and get started. The alphabet guy up here is what gives you the ability to enter text of various forms on the screen, including just text, including Greek characters, upper and lower case, lower subscript, superscript. This will put a new line, so if you want to have a multiple line entry, and then some special characters that you can use. Formatted text, I don't generally use that, but if you feel free to play with it, if you want enter text here, or paste it from an application, you can read it just as well as I can. The input variable is if we want to use this as a graphical user interface, in essence, a GUI. So we might do that at the end of this lecture. The first thing we're going to do, though, is put output variables in. I will generally make my output variables in a dark blue. And my input variables I typically make a dark red. So we'll get to that when we get to that. In the meantime, you must click OK here for it to register. Background color generally is defaulted to white. You can have no background color if you want, or you can change the different background color if you have different colored text. You can set the angle. I also usually like it bold. And I want it to be shown all the time, not just after calculation. So if you want to hide the output variables until a calculation is performed, you can do that. So let's go ahead and do this. And sizes, notice this says 24 point. That's probably going to be a little small. Let's see. Yeah, that's a little smaller than I want. And that was the first item in there. I don't really want fluids. What I want to do is I'm going to set up the same way I have here. Mass flow rate, temperature, pressure, enthalpy, entropy, and quality. And I don't care about the rest of the variables for right now. I like to include quality because if I start playing with this and change the fluid from water to another substance, it will tell me whether I'm still in the steam dome or not, because if it goes over 1, it goes to 100, that means it's superheated. If it goes under 0, it jumps to negative 100, that means it's a subcooled liquid. And depending on where I am in the system, I may not want that, so that fluid may not be appropriate. So I like to put those in for that purpose. So we're going to start with M dot, click OK. Oh, and I wanted the size to be bigger, so cancel. Properties. Let's go to maybe 36. That looks pretty good. All right, so 36, M.1. Drag it over to state point 1. Actually, that's a little big. Make it 30. Get everything sorted out early on. Oh, and we want to show units. It's not showing units. That's an option. So we want to go ahead and show units. Okay. If you have alternate units listed, you can show alternate units, but on the diagram you can't show both, but you could put two output variables. You could have one with one unit and one with the other unit. All right, so we've got 50 kilograms per second. Now, the easiest thing to do is just copy and paste. So I'm going to make, we want temperature, pressure, enthalpy, entropy, quality. So 5 more. So I'm going to copy it, and it will disappear. The outline will disappear. And then I'll paste it 5 times. 1, 2, 3, 4, 5. They're all on top of each other. So I will move the whole stack down, click off, and then move each individual one down. We should have 6 at the end. So I didn't mean to double click on that. I move out to the side. Yep, that's good. I'm going to move this down a little bit. It's a little too tight of a group. The other thing I can do is we can select, and let's make this a little bit bigger, give us a little more room to work. Select all of those elements. Use the Align tool here. If this toolbar disappears, say it was over here and you did something like that, it disappears. You don't have to go back over there. You click on this, it goes from development to application mode. Click on it again, it goes back to develop mode, and it will be back in your view. So that's convenient. And we want to reselect these guys. Use the Align tool. We want the left sides to be aligned, spaced equally. Okay. That's a beautiful thing. Now we'll just individually change them to, what did we want? We want temperature. Actually, I want pressure first. So pressure, then temperature, then enthalpy, then entropy, and then quality. And we're good. Sometimes when you calculate, when you have quality in the superheated or subcooled range, and you've asked for quality, it will give you an error signal or a warning window. Just ignore it. It's fine. If you look at your array, it will show up as minus 100 or plus 100. Just be aware. It's basically warning you that you're outside of your parameters where quality is a valid item. So now what we want to do is we'll select that and we'll copy the whole thing. And then we'll paste it. And we're not going to paste multiple copies on top, because if we do that, we're going to drag all of them around. And we don't want to drag all of them around, because after we do the first one, we have to individually select for making a new group, because we can't do a batch select with a enclosing rectangle. So let's go ahead and just move it, copy and paste again. Get rid of that. Oh man. All right, see if I can. So I want to get it just, there we go. I should have just these guys. Yep. So m.3, so this will be state point 3. And copy and paste one more time. State point 4. Okay. Now we just go through and tediously change all of these. I'm going to pause while I do that. Actually, I'll do the first one. Sure, it's not that hard. Oh, we already did it before, so I'm going to pause and finish these up and then come back. Okay, you can see I got all of the state points in 1, 2, 3, 4. Everything is good. Notice this is uppercase. I'm not sure why. Ease does not care. It ignores case. So I'll probably fix that at some point. But in the meantime, it's moot. So now what we want to do, let's go ahead and add in, we also want to put in, let's make a copy here, Command C, Command V, twice. And what we want to do is put in a turbine power and the pump power. So we'll have to edit those. Those are our W dot turbine. Okay, and maybe we want that slight highlight on that because that was something we looked for, and we can do the same thing here. And just to show you the difference, I'm going to make this alternate units and value. Okay. Okay. Oh, I didn't change the highlight. So I'm gonna go back to kilowatts, but you can see how you can do that. You can select the primary units or the alternate units for your display, but let's be consistent and go with standard units, and we'll also select the same highlighting. Click OK. Okay, so we've got everything we've calculated pretty much. We don't have specific work. We don't really need that on here. That's a useful thing for some occasions. And what we want to do now is add a calculate button right up here. Add a calculate button, just a simple calculate button. And we can move it right over here. And let's change, what do we want to change? Let's change the pressure at P2. So P2, we gave the pressure, right? 6 megapascals. What we're going to do is put an input variable, and it's going to be for P2. Okay. And like I said, I like my input variables in a dark red. So I'll pick on this, and that's not dark enough. I like it a little bit darker. I like that. Add it to my custom colors. So now it shows up over here. Click OK. And background color, I want to be white. Okay. And anything else? Nope, that will be good. Okay, so it shows up right where I created the last one. So I'm going to put that up here. And what do I want to do? So, yeah, I'm going to put it over here because I want my input variables separate from my output variables. We've already got it here, but I want to be able to change it, and but I want to have it, all my changes, if I have multiple input variables, I want them all in one location. It makes it easier to make changes in the future. So let's go ahead. Now, if I try to calculate that, it's going to give me a problem. Okay, with the values already previously defined. We've got it over here in the equations window. So we either have to comment it out or make it so that when we're in the diagram window, it ignores it. So what we're going to do is I'll show you what happens. We're going to have a problem here because that's megapascals, and if I type in 6,000 kilopascals, that's going to be a problem. But let me show you. So what I'm going to do first is I'm going to put this on a separate line. I'm going to move this out to the top. Doesn't have to be at the top, it could be someplace else. I just want to isolate it a little bit, and then we're going to give a directive if not diagram window. P2 equals that value, and then $sign end if. And you don't need to do this. I like to put a little tab in to offset it so we can see that we got an if-then statement going on, or if-end-if statement going on. So now, if I click on it over here, it works because it's ignoring the diagram window. If I click on it over here, it also works. Sort of. No, it doesn't. Something's wrong here. So I was in error. I forgot to set the units to kPa. So since here we converted it to kPa immediately, so the units are kPa. But if I wanted to put megapascals in, we could do that. Let's look at. So let me go back to the mode here. Take a look at it. I don't think we have alternate units in. We do not. So what we need to do is go up to, get out of here, give it so for P6, not P6, P2, we want the units to have alternate units of megapascals. So megapascals. And for the most part with units, capitalization does not matter either. However, certain ones do, like capital M is mega, small m is milli. So now I can select this properties, alternate units, and value. Click OK. 6 megapascals. So now calculate. Oh, got to go back into, and say we change this to 5. Let's see what changes. We got almost 50,000 kW, 300 kW there. Change that to 5. And it came down significantly. See that? So that's an input variable, and it allows us, now if we go back over here and we run it, we're going to get back up to, it stayed the same, so that didn't work. Okay, so for that to work, you have to have the diagram window closed. So let's go back to 5. And we've got a value in the diagram window, so the calculate changes everything. Okay? And it will also change everything in the array to accommodate the fact that we changed that pressure. I like to put this down here so I can just readily access it also. So now if I try to solve this, we have a diagram window and it's open. And this didn't change, right? because it's looking at the diagram window. If we close the diagram window, and now we hit it, this should go back up to whatever it was before. 66,000 was it? 66,000 here, 49,000 here. So 49,000. What happened was the diagram window. Close away, diagram window. And we're at 6. Let's make this 5 again. So actually it's increasing a little bit as pressure drops. Okay. So that is that for setting up the diagram window and setting up input variables, output variables. In order to run the program without the diagram window, you have to hide the diagram window, and it will run based upon the data in the excluded variable area. If you have the window open, it will just take the input that are in the diagram window as well as whatever is not excluded over here and do the calculations for you. So let's do a quick plot, and I will show you what the problem is, and then the next video will be on property plots and plot overlays, and we're going to change from a 4-point to a 6-point plot. You'll see why in just a minute. So property plot right up here, this icon, or under plots you can pull down property plot, and we're going to want a TS diagram, and we're dealing with water. Okay, and I only want 2 state points, and we want 6,000. That's our high pressure. I believe our low pressure is around 62 point something. 62 is close enough. We don't want lines of specific volume or enthalpy. We do want lines of constant quality. That's always convenient. That's what I want anyway. And we'll make the line blue. Where's blue? There we go. Doesn't really matter, but I want my other line to be red for the state line. Or not the state line, but the state points. So we've got the property plot. TS water, property plot. Now we can overlay a plot. Again, under plots, you can pull down to overlay plot, or along the top here, we've got overlay plot as an icon. So we want to overlay from the array table, rows 1 through 4, automatically update. So if we change pressures and temperatures or anything, it will modify the plot for us. And we want the entropy to be on the x-axis and temperature to be on the y-axis. And okay. We use the same scale on both. Show plot. I want to make this like a nice little fat dot. Make this a little bit heavy. Make this red. And click OK. Now, there's the problem. I forgot to put the, let me get rid of this. So when I go into edit, I can say I want to edit that line. Notice these are our constant value plots. So we could put in extra constant quality plots if we wanted to, but we're not going to. I'm going to go ahead and delete this, because what I want to do is change the overlay plot so that it shows the numbers. What did I just delete? Oh, I didn't delete it. Delete. There we go. Click OK. Go back to overlay. And we want entropy and temperature Same scale. And we want automatic, add point labels is the other one. And we want to connect the last point to the first point. So point 4, come back to point 1. And the similar changes we made before. And red, and away we go. So 1 and 2 are right on top of each other. Very little change. We're a little bit below 62. I think I was calculating something. Oh, that's because I think we're on 5 megapascals. It's 62 at 6 megapascals. Okay. So what happens though is what we want is to come up to here. Make that, I don't know, orange, I guess, or dark purple. There we go. And we want it kind of fat, so we can see it a little better. So we want it to come up to there, and then across. And then up. Okay. So, in order to do that, we have to add a couple of extra state points. We'll add one here where it changes from a subcooled liquid to a saturated liquid. So we know the pressure and we know quality is 0. Here we know the pressure, quality of 1. And then this will become state point 5, state point 6, and it will come back across. So we will do that, and we will also create some code that will automatically draw these based upon what we program. That's it for this lecture. This is slightly less than a half hour, getting a little better.